In this lesson, we will finish automating the movement of the smaller arms. Let's go ahead and grab bone A, and we'll go ahead and basically take its expression so we can use that to apply it to the other bone objects. We'll go to our motion panel, go ahead and find our Z controller. There it is. Let's right-click and choose Properties. Let's go ahead and copy our expression. And now we'll go to Object B. It's going to be rotations or Euler. Let's assign our float expression controller to its Z-axis. We'll paste in our expression, and now we'll go ahead and type in our variable molt, choose Create, and assign it. So we'll search for the multiplier. Alright, there it is. Now let's go ahead and see what happens when we use the current expression. We'll go ahead and click on Evaluate, and we'll play this back. We'll notice that we're not getting this type of cycled behavior. Instead, what we're getting is more of a bicep bulge, almost like the creature is working out. So what we need to do then is work with a cosine function that plays along with our sine function. Now with cosine, the difference between sine and cosine is that cosine starts at the top of its value and then it continues in a wave pattern, whereas sine starts at a value of 0. So when we go ahead and switch this here to cosine, watch this. Now when we evaluate, you'll notice that we're getting that type of cycled behavior that we need in order for this to feel creature-like. How cool is that? Now here's an issue. If we were to go ahead and zero out our multiplier, we'll notice that the arm does not pop back to its skin pose. That's simply because, again, cosine, it does not start at 0. It starts at its high point. So how do we create an expression that says, all right, we want to make sure that when this value is at 0, that this value for the bone object being affected by the expression will be set to 0. But if not, then we want it to read the rest of our expression here. How do we do that? Well, we can work with a condition statement. So it will read as follows. If our multiplier is greater than 0, then it will go ahead and look at this part of the expression. If not, it will look at a value of 0 so we can set it back to the skin pose. So how do we build something like this? Well, that's the beauty of working with the function list here. We can go ahead and take a look at the format that we would need to create our condition statement. Here it is. So that's going to be if, and then we'll need to wrap everything in parentheses and create a condition, a true statement, and then the false part of our statement. Let's go ahead and build this out. So again, we'll wrap everything we have here in parentheses. And now, at the very beginning here, just outside of our parentheses, we'll type in if. Now, after the first parentheses, we'll go ahead and type in molt greater than 0. And we'll put a comma and space. So we now have the condition part of our statement that says if molt is greater than 0. So if that's the case, well then we want the expression to look at this part of our code. Now if that's not the case, we need the false part of the statement that sets the bone back to 0. Alright, so here's what we need to do. We'll go ahead and put a comma after the 0.5, space, and then 0. So just before our last parentheses, this is what we should have. Now watch. If we were to go ahead and choose Evaluate, you'll notice that the arm is going to pop back to the skin pose. How cool. If we were to go ahead and select the center of gravity and set this value to about 0.1, take a look. We'll notice that the arm is again moving in that cycled pattern. How awesome. Alright, so let's go ahead and copy this because we'll need it to take care of the last part of that arm. So we'll go ahead and grab bone C here. Let's go ahead and move over to our motion panel. Let's go ahead and find the Z-axis and assign another float expression controller. I'll go ahead and close out the other page. So we're just focused on this one. We'll go ahead and paste in all of our information here. Let's go ahead and type in molt. We'll go ahead and create the variable, and we'll go ahead and search for the multiplier. Here it is. All right, now, if we go ahead and evaluate this, take a look at what's going to happen. Let's play this back. And we don't quite get a full cycle of behavior out of this arm. Instead, it looks like the arm's kind of digging. For this to look creature-like, what we need to do is go ahead and take our range part of the expression, which is this 0.5 here, and let's go ahead and set that to about, let's say, negative 0.5. When we now choose evaluate, watch this. When we play this back, now it looks like the arm's starting to kind of grab at us, and it looks very creature-like now. Cool. All right, we can go ahead and bring back our creature to take a look at how this has all come together. Go ahead and play this back. Exciting. So there we have it. Now, how do we create this type of delayed behavior for the other arms? All we need to do is change our frame multiplier. So instead of 200, we could start to drop that value to, let's say, about 195 for the next arm, 193 for the next, 191 for the following arm, and for the last one, we can work with about 189. But as long as we start to change this value, then we can start to create that delay because we're delaying our frame at that point. And then once you're finished, you could go ahead and take the very same expression and you can go ahead and bring that over to the right side, and that will cause the arms to alternate. That's simply because we have mirrored them using our bone mirroring tool. So it has caused their axis to be flipped. That's why it works the way it does. All right, super cool. So I'll go ahead and leave that part up to you, and you could use this file as reference to figure out the frame offset, but I've just read them back to you. Again, for the other arms, that's going to be 195, 193, 191, and then 189. I find that those values work very well, and we're replacing that 200 with those values. All right, so again, I'll leave the others up to you, and that'll essentially finish out our rig. We'll just go ahead and double check to make sure everything is good before we move to animation, which we're just about ready for.